Welcome, geeks, to another exciting episode of Rockin The Code World with dotNetDave. And this is the 100th episode. Woohoo! Party time. Simon and I were just talking about this before the show. It seems so long ago since we started the show, Simon, and we've had so many awesome guests and topics, and I've really enjoyed doing the show, and Simon, I hope you have too, and I hope all the thousands and hundreds of thousands of viewers have watched the show, have enjoyed the show. I'm very, very appreciative of all of you out there who have watched the show. This show is for you, so I have to give a thanks first and foremost to the viewers. You hang out and watch the show, especially the viewers who watch live. I'm very appreciative of you all watching the show in the fourth season now. And so thank you so much for watching the show. I hope you keep watching. I hope you go back and watch some of the past episodes. Like I said, all of my guests have been awesome. And I think every episode's got something you can learn from. So I hope you go back and check them out. And I also want to give a shout out, of course, to Simon, my producer, who I couldn't do the show without. He's an awesome young guy, and so he can stay up late at night in India and produce a show for me. And I'm really appreciative of Simon. And like I said, I couldn't do it without him. And he's not only he's a great guy, but he's a great producer and helps me when I need it, and suggests guests for me. So some of the guests coming up, you'll see the rest of this year has been suggested by Simon. So I rely on his guidance. But so thank you, Simon. Thank you so much for helping me do the show and making it as successful as it is. And I think this is still the most popular show on CSharpCorner. So we'll see. Maybe we'll make it to 200 episodes. We'll see. Okay, let's get going. I'm super excited to have, for the fourth time, he's been on the show 4 times more than any other guest by themselves. Mark Brown. I'm excited to see Mark Brown again. He actually stepped in because the speaker who was supposed to speak today had to drop out, and I mean the guest for my show had to drop out. So I'm really appreciative of Mark jumping in and filling in, and I kind of want to find out more about all the cool things happening with Cosmos DB. I really like Cosmos DB, and I can't wait to look. I'm really looking forward to and working in production, hopefully in a company I can find. And because I really like Cosmos DB. I'm still not very good at the partitions, but you got to learn. I come from the relational database background, and I'm still having a little bit of a learning curve when it comes to document DBs. So anyway, show number 100. Woohoo! Oh, I put sound effects in this, but you're not going to be able to hear it. But there we go. I was going to talk about the 100 while that was playing. Yeah. So anyway, there's the fireworks for my show. That's enough. And so, because I want to leave as much time as possible for Mark to talk about all the cool things with Cosmos DB. So, you all know that I released the 8th edition of my coding standards book earlier this year. I hope you go pick up a copy. It's the biggest book I've ever released by myself. It's 560 pages. You can get it in paperback and hardback now if you really want. If you're going to the conference I'm speaking at in London, I'll be giving out some hardback, hardcover copies at the conference in London. So make sure you come prepared to participate in a contest. That's all I have to say. But please go to Amazon.com, pick up a copy. Most teams, I work on either have no coding standards, which is really bad, or very little coding standards, which is not much better. So this is a comprehensive book on coding standards, the only comprehensive .NET book out there. And so I'll go pick it up. All right. Also, I've released new versions of my Spargin projects, Spargin 8 now, and you can go get the source, or you can just use the NuGet packages. And since I'm currently working on the new edition of my code performance book, I've made lots of changes to Spargin, actually this week, to make it even faster. So the next version, the next full release of Spargin will even be even more performant than before, because some of the things I've uncovered for my book. And so I hope you go pick it up. And also, while you're out there, pick up a copy of the Spargin Dev Tool. It's a completely free global tool for software developers. It helps you quickly clean out cached and temporary files from your system. Actually, I ran into an issue this week, and I ran Spargin, and the issue in Visual Studio went away. So that's one of the reasons I really like my dev tool, and it helps me do really quick backups. I'm getting close to a terabyte of backups Spargin has done. This version of Spargin has done. So I'm very anal about the backups, because I hate losing code, and so Spargin helps me not to lose any code. So I'm really glad about that. And last time I checked the logs, there's somebody in Manchester, England using it. So if you're watching, I'd like to hear back from you. So I get to see who's using the app when I go onto the Azure portal. So I like to keep track and where you're using it in the world. And so anyway, I hope you go pick it up. And before I introduce Mark, I want to make sure if you have any questions about Mark or Cosmos DB or Azure, make sure you start putting them in the chat now. It takes a couple minutes sometimes for the questions to come through, because I want to get your questions answered. And also, if you're watching live, I know I don't get a lot of live people during the show, but if you're watching live, please put in the chat where you're watching from. So I know you're watching, and I know where what country is watching. So please do that. All right, the interview. I want to welcome on, for, like I said, for the 4th time. Mark Brown is a 20-year Microsoft veteran, currently works in a Cosmos DB team and oversees all of their developer outreach and community activities. Welcome, Mark.
Hey, Dave. Great to be back, and happy 100th episode. I'm actually quite honored you would think of me to come and speak to you today. So great to be here.
Yeah, I'm glad I had somebody on from Microsoft. Well, I'd be glad anybody really, but I'm really glad somebody from Microsoft is on because most of us are Microsoft software engineers, right? I got my C Sharp
Oh,
hat on,
I don't
and
have one of those.
no, most people don't. I had to beg one out of Scott Hunter. I think actually he sent me Scott Hunter was the very first guest on my show. And I think during that show, he was wearing one of these. He was in his car, and because the power went out, or I don't know what was going on, but he was in his car in one of the parking lots at Microsoft doing the show. And I go, where do I get one of those hats? And so he sent me one.
He did a show in his car.
Yeah.
He has an office, I mean, he took a
like, like
conference room and made it into his office. So I mean, it's a little focus room, but still.
Yeah, I had to go back and look at the show, but I think the power was out or something. I forget. Simon might know. Let me see if Simon said anything.
He's during the pandemic. Well, we still
Yeah,
had
it was during the
power,
pandemic. Yeah.
but we still had power.
Yeah, something was happening. I forget
I
something
see.
was going on, and I forget what it was. I'll have to go back and watch the show.
Huh.
But,
Well, I'm gonna have to go and bug him for a hat, maybe. If he still has it, maybe he probably doesn't anymore. I'm sure. So
I don't know if they have them anymore. They're kind of internal to Microsoft kind of
oh,
things.
so super rare.
Yeah, very rare. Yeah.
Okay. All
And
right.
yeah. So
Well, it's good to be on. I'm going to talk about all the new stuff that we are doing in Cosmos and have been doing for about the last year. We've been focused a lot in the last 12, 15, 16 months on enabling AI applications. Like since ChatGPT kind of hit the universe back in, what was it, November, was it 2024? So it's 2022. So I think in November 2022,
yeah.
OpenAI released ChatGPT. And then I basically spent like all of Christmas break messing around with it, writing code, looking at it like, man, this is fantastic. Like I'd see anything like this in decades, maybe, or nearly decades, for
Yeah.
just how awesome it was. And we've been busy in our service making Cosmos basically the best database for building these types of applications. And so I've got lots of stuff to show you and show the viewers here. So I have some slides, maybe if I can start with
Sure.
kind
If
of
you want
laying
to
some
share your
groundwork here,
screen.
and I can highlight kind of the stuff we're working on and kind of helps level set if people are still haven't gotten too deep into this stuff, or maybe been ignoring it, or they've been busy. And then also kind of show folks what we've done as a database to make it easier to build these types of applications. And then also I've been busy building like tons of samples and other stuff as well for folks, just so they can get started, and doing it in .NET, by the way, because for those that have been trying to build applications, it's very Python heavy, I guess is what I would say. But that's okay. I'm a .NET guy. Actually, I'm a Python. I had to teach myself Python over the last year as well, just so I can kind of hang out with these cool kids. But at my heart, I'm a C# developer. So a lot of the stuff I produce is all in C#. So anyway,
well, before you do your slides, I want to say real quick, I think I use ChatGPT pretty much every day now, especially when I'm working on my book and to help me edit. And actually, speaking about HI, the image you see behind me, I made this morning really quickly. It's an AI generated image I made in just a couple minutes on Adobe Firefly. And, I said, hey, I'm celebrating 100 episodes. And I did a couple other little tweaks, and that's one of the pictures that came out. So
Dolly's amazing. In fact, I've
yeah.
got some Dolly generated slides in my deck as well. So I'll see if you can figure out which ones. Might be quite obvious.
Ever since Firefly came out, I hardly use stock images at all anymore. I just say, hey, I've got an idea. I stick it into Firefly. I fart around with it sometimes for a long time, and sometimes some really great stuff comes out.
It's amazing how well this just, I don't know.
Yeah.
It's hard to put into words, right?
Yeah.
Actually, I'll just let ChatGPT put it into words for me.
Yeah, I'm really can't wait to try out the ChatGPT video feature that
The vision.
they're testing right now. I can't wait for that. Yeah.
Yes. Yes. There is some stuff coming. I can't say exactly when, but there is some stuff coming. So stay tuned for upcoming big conference.
Yeah. So I'm excited because the one thing, because anybody who watches my conference talks and everything, they know I use a lot of video and things like that, and it would be awesome if I could just have AI generate that for me, then to do it myself.
Well, we keep going down the slippery slope, Dave. It's going to replace us on stage as well, probably.
Oh yeah, I'm soon. I mean, well, look, Kiss has already turned themselves into avatars now. They're not going to tour live anymore. They're only going to do avatars now. So they figure, I guess they figured they're too old, and now they're just going to do AI generated crap now. So
it's Gene Simmons and Paul Stanley and Ace Frehley. They're just going to sit on the couch getting fat, and their avatars are going to stand on stage.
They already are. They already are fat. So. Especially Gene Simmons, man, he's really ballooned up lately. But
he probably can't even bend over to put on those big platform boots of his anymore.
No, Paul Stanley still looks awesome. He's been posting some pictures this week. I guess he's on vacation in Dubai, and man, that guy, for being in the 70s, looks freaking awesome. I know he's had a lot of plastic surgery and everything, but still, he looks really good.
He's following Keith Richards' diet advice or something, I think. So,
well, luckily he doesn't do as many drugs and everything as Keith Richards does. I think that's why the Stones are still here. They're petrified, right?
That's right.
Anyway,
minerals. All right.
Yeah. So, let's talk about.
Let me get into kind of where things are at. So, as I was kind of leading off here, ChatGPT has just kind of changed everything, and ever since it came out like 18 months ago, companies are looking at kind of the existing stuff they've built, or how can they leverage this thing in new ways. And what we're seeing is kind of across the spectrum, we're seeing people implement these generative AI types of technologies into doing things like building connected smart products. In fact, at Build, you're going to see a company called TomTom. Remember those guys back from kind of the 90s or the 2000s? They did kind of all the in-car navigation. They're now building like a complete smart car cockpit solution that is all using ChatGPT, all using generative AI, and you can completely control everything in your car, do navigation, say, hey, find me an Italian restaurant and then book me reservations and turn on my lights and do all this other stuff. I'll do it from voice within your car. Other stuff like just transaction, like boring things like doing transaction processing at scale and being able to analyze the transactions that are happening, and including things like real-time fraud detection. And this is really what's interesting is you don't think of this technology as necessarily something you can do fraud detection with, but underlying these technologies like ChatGPT are these things called vectors or embeddings. And within like this vector space, you can use this to analyze transactions or things that are happening that are outside of those vectors or outside that vector space from a dimensionality point of view. Of course, building things like service and support bots, like those have been around forever. In fact, a lot of companies have been using Cosmos for building those. But of course, when you have generative AI, you can have a richer experience with customers to be able to interact with these types of things. Of course, doing and also using those things to find products or get information on stuff. This is a huge use case we're seeing now as companies are taking all of the existing data and knowledge that is stored within their SharePoints or stored within their data estates, and then vectorizing this stuff to make it easier to find information that their employees or their customers or whoever need. And then, of course, this vector search technology, as well as just being able to take and do things like product recommendations using traditional ALS or ML models. You can take and do personalization and recommendations on these types of things.
Yeah.
And then, of course, underlying this as well is like everybody's building your own Copilot for whatever. Like, just take a look at Microsoft. It's like kind of the .NET Dave. Remember Remember when dotNet came out in like 2002? And
everything had to be dotNet.
Everything is dotNet.
Yeah.
Right. Well, it's guess what? It's
even
happening
Windows
all over again, Dave. It's everything.
Even
Copilot,
Windows.
Copilot, all the things, and we're building Copilots up and down the entire portfolio of essentially everything that comes out of Microsoft. There's a Copilot for it. An Azure Copilot, an Office Copilot, Teams, and of course, companies now building their own Copilots as well.
They are. Office is doing it. Yeah.
It's huge, the applications that are there, and these are the things we're seeing across kind of the industries.
But you're right with the data analytics, right? AI can really help processing data analytics, especially with fuzzy logic and things like that, and just to make it so much easier for us to do as opposed to instead of us trying to figure out all the parameters, the AI kind of figures it out, right?
And you bring up a good point, and this is a scenario that I'm working with some others on right now. Is we have this thing called Microsoft Fabric, which is kind of like this one lake of information. So the idea is bring all of your analytics and bring it into one place, vectorize it, and then being able to do natural language queries over this. Like, hey, my sales are up 10% last month. Why? Can you tell me what's going on, right? And you can have these things, and if you vectorize this data and of course do it in an appropriate way, you can go and get insights by asking natural language questions for your data in something like a data lake or in your data estate within there. So this is another big scenario that's going to be coming in a very big way. Like, it's all starting to come together now, and you were going to start seeing over the next year or two this stuff really come together in a really meaningful way.
And actually, I think it was 3 episodes ago, Simon, you can look it up for me, but I had actually I had a PhD on my show. I met when I was in Lithuania, and she came on the show because she is a natural language processing expert. That's what she does. And it was really enlightening to listen from her aspect, about AI and how it kind of works under the covers and everything. So anybody watching, I would go back and watch that show too after this one, just to learn more, just exactly how this natural language processing works.
Yep, it all ties together, right? And that is kind of how you interact with these models, is obviously with natural language, right? And that could be speech to text or just typing or both, right? So so for Cosmos, for the last year and a half, we've been busy. Like, how do we make Cosmos the best database for building these types of generative AI applications? And there's 2 main flavors of Cosmos that we're bringing to the fore for customers to help build these things. On the right, we've got our Azure Cosmos DB from MongoDB. We just GA'd this back in November at Ignite. And this is built using native vector search technology. So we have support for this vector technology called IVF, and then another one called HNSW, which is kind of the industry standard. So things like Pinecone and Milvus, Postgres Vector, all the vector databases you see in the market today are all built using this HNSW, which is a kind of graph that allows people to do kind of a vector, or not kind of do, but do vector searches over their data. So you take data in your database, you vectorize it, store it in your database, and then you can do this new type of query, this vector search on it. And what's nice about how we're doing this versus, say, a Pinecone or a Milvus is our Cosmos DB from MongoDB is still a natural transactional operational database. So you store your vectors and your operational data inside the same database, inside the same document. This is unlike what you would see in the market today with purpose-built vector databases, where they are essentially made for just doing vector search. Our database is still a transactional database. And the nice part about this is you don't have to ETL the data out of it, generate vectors, and store that in another database. You generate vectors when you do inserts and updates, and then do those as in the context of a transaction. So if I want to add, say, a new product to my product catalog, or add a new sales order, or add whatever, vectorize the data, and then do the insert or update on that within that same transaction. So it's an all or nothing type of thing. And the other nice thing as well is, because it's there inside the database, it's available immediately. There is no lag between when you do that and then you have to ETL it and then stick it in a vector database. So it's cheaper and also easier to be able to do. So this has been hugely popular with customers since we GA'd this back at Ignite. It's just exploding in terms of the growth. People really love it within there. Now, on the left side is our traditional Cosmos DB for NoSQL. This is the database that, Dave, you have been struggling with, right? On scale-out database.
Partitions, yeah.
Right. Well, our MongoDB, our Azure Cosmos DB for MongoDB is a vCore base, so it's essentially hosted on like a VM. You can partition the data, but the idea is that this thing can scale up. So you just provision bigger and bigger compute instances, and then you can get attached storage to this. So you can get multiple terabytes of data, and then partition that data if you want, or just have it all within a single partition. And then, of course, for the NoSQL, that's partitioned. So you still have the 20 gig partition size within there. So it's a scale out database, right? And the idea and the reason you want that is you get this really extreme elasticity within there, instant auto scale. So if I have 0 transactions and then 1 million transactions, no problem, right? We just automatically scale that thing. It's ready to go. Also, there's a serverless as well. So if you don't have any transactions, or if you're just doing dev test, that's fine. Use serverless and just pay for what you use. You get like about 1 million reads for 25 cents. I mean, it's really affordable and really cheap to use. Of course, all of this is built to be super mission critical, extreme low latency, really built for kind of these real-time mission critical transactions. And then kind of the icing on the cake here is at build, we are going to announce a new vector search technology called DiskANN. This was developed internally by Microsoft Research. And what's beautiful about this is just its capabilities and how well suited it is for running on Cosmos DB NoSQL. So let me go another slide or two, and I'll show you why this is so amazing. So today, companies are using Cosmos as a vector database, whether it's for NoSQL and storing things like chat, or our Mongo vCore for doing things like building RAG pattern applications or retrieval augmented generation. That's the whole kind of the application pattern where you have, say, a user question or query like, hey, show me some interesting products you've got, maybe show me some bikes or whatever. And then your application would go and do a vector query using product data that's vectorized, and that returns back the best results for, or the things that are closest in that vector space to that query. So if you're looking for bikes, it's going to find all the products that have vectorized bike data within there. And then it'll return it back in descending order of how close or how similar those results are to the user query. So that's the main app pattern that we're seeing, is this retrieval augmented generation, just call it RAG pattern. And then, of course, the other big use case is in chat history. And this is another place where we're seeing, especially in our NoSQL offering, people using that service to capture all the chat history. And the reason is you want to be able to take and gain insights from what customers are doing. Maybe it's trying to gather sentiment analysis or getting insights. Maybe you want to fine tune your applications, or even maybe auditing and optimizing these things. And then kind of the fourth category is people doing this new thing called semantic caching. And the idea there is you have users that come in and ask questions, and in many cases they will ask the same question. Well, could we make that even more efficient by not even going and doing a lookup in a database? Can we just serve that from a cache? So that's possible. You can do that. And a lot of these new SDKs that are built for doing RAG pattern applications like Semantic Kernel and LangChain, Llama Index, all of these are now starting to support this notion of the semantic cache, so that you can return that data much more quickly and easily.
So what you're saying is, like, if someone comes in and asks, where is the totality of the eclipse on Monday, you can catch that, and now it's not being hit against the database anymore.
Exactly, right? So you could use a semantic cache for like building an FAQ, if you will, right? And make that even faster and easier. And by the way, this is even more important now than it was, say, a year ago. Like when ChatGPT first came out, it was using this foundational model called, oh gosh, now I'm having a brain fart, DaVinci. And then another one came out. It was GPT 3.5 and 3.5 Turbo. And then GPT-4 came out. And what we're seeing is that the latency for these models, they're better models, but the latency is getting higher. So GPT-4 is significantly slower in generating responses than say GPT 3.5 is or DaVinci 3 on there. So, in the context of creating a great user experience for customers, why keep going back and generating the same response over and over again if you can take the question, cache that with the answer, and then just return that? So that's going to be faster. It's also going to be cheaper.
So is the semantic caching automatic, or how does that work exactly?
It depends. So, I mean, right now you more or less have to build this type of capability. Some of the orchestrator SDKs like LangChain are now making this available, and there are others like Semantic Kernel that's also came out of MSR are also building these types of capabilities. So everybody now that's in this space are building these types of this functionality so that you can take the chat history that you are capturing and then being able to serve that up to be able to answer questions from users.
Yeah.
So on the chat history side, it's important to store that. This is an LLM or a Dolly generated application, but why would you store chat history? Well, you've all heard this phrase, your call may be recorded for quality assurance. Well, that's important because companies want to make sure that the information that their customer service agents are giving to their customers is accurate, that they are staying on script, that they are not misleading them, that it's all about quality assurance, right?
Yeah.
I mean, essentially what they're saying in there. And this is a human to a human type of interaction. These models like ChatGPT, can sometimes hallucinate and sometimes give bad information or just otherwise not provide accurate information that you want, right? The information that they've been trained on or that you were trying to get them to do. So recording these interactions is super important so that you can ensure that you're going to get the best quality responses out of this thing, or at least use that to analyze it so you can make that better.
Sure.
So storing the chat history is a critical part for building any of these types of applications. You really want to capture all of this information and then store it so that you can save it and then analyze this information later.
Yeah.
And
like logging in an application, right? If you don't have the logging, there's no way you're going to be able to figure out why things are happening, where it's happening. There's no way, right? It's impossible pretty much.
That's exactly right. Yeah. Just like you were going to log anything in an application, you need to log those interactions that are happening within there.
And like when I'm, go ahead.
Oh, no, go ahead.
Like when I'm using Firefly and I'm telling it, no, this is incorrect, and I don't know if this is happening, but I'm assuming behind the scenes, they're recording that and someone, or maybe AI is going back later and looking at that going, okay, why is this incorrect? When I was making the graphic you see behind me, the one thing I've found with these text to AI, they're really bad at counting or putting words in anything, right? And so when I made this image behind me, I said, I want 100 in there, right? And it comes up usually with everything but that, right? and so whenever that happens, I, do the down thumbs down on Firefly, and I'm hoping they're looking at that going, yeah, you didn't do what I wanted here, so.
They all do this, or they should be doing it. They're not doing it. But yes, everybody that's building these type of applications, and that's exactly why, because it provides kind of a binary way of kind of segmenting that data. Like, oh, this is good. Let's see why. This is bad. Let's see why. Right. So absolutely important. You got to be capturing that chat history in there.
Yeah.
And in fact, customers are using Cosmos NoSQL to do this. And in fact, even before ChatGPT, lots of customers in Azure were using Cosmos to go and record all their chat history. In fact, we were just talking about the pandemic. I mean, anybody that during that pandemic knows or has used like Teams, right? Because you were doing all your meetings at home. Well, guess what? All of the chat history in Teams is all stored using Cosmos DB.
Yeah.
And in fact, Teams was already a massive global service. It exploded when COVID happened, absolutely exploded. Yeah. And one of the reasons they were able to do so is because Cosmos was underlying all of that chat capability in there. And Cosmos, being built as a scale out database, was happy to be able to just continue to scale out and support Teams as more and more users started using it every day, logging in, having meetings, and doing chat conversations over that within there. In fact, just to put a fine point on it, even ChatGPT itself launched with Azure Cosmos DB, storing all of the chat history within there. Wow. It went from nearly 0 users to over 100 million daily active users. I think it's even higher now. Like it's had over 180 million daily active users in there. All of their chat history is all stored using Cosmos DB for NoSQL in there. And that was a big part of why they wanted to use it. They weren't using it when they first started, but they quickly realized that it was becoming a bit of a nightmare managing all of the data underlying that thing. They had to keep going and provisioning new databases or resharding and doing all of this manual work to their data underneath. And we came and said, we can help fix that. And they went and used Cosmos DB. Essentially, once they provisioned the account in there, they really didn't touch it afterwards. So all of that growth that happened from 0 to 100 million daily active users and beyond was all done on Cosmos DB in there. So this is if you want to use the best database for building these types of chat applications or generative AI applications, you absolutely want to use Cosmos to do all of your chat history.
And because that's, to me, when I talk to people about why they should be looking at something like Cosmos DB is, what you just explained would be really hard to do in a relational database, right? And Cosmos DB, it's not hard at all, right? It's pretty much unstructured data for the most part, and you just throw anything you want in there, and you can't do that without jumping through a lot of hoops and a lot of things. What you're saying, like the maximum database sizes and things. If you were using, something like Microsoft SQL Server or something, right?
Well, they weren't using SQL Server, but they were using another very popular relational database.
Yeah, and that's for stuff like this. Relational databases really don't work, right? Pretty well.
Not for this kind of scale. When you're trying to go petabyte size storage or hundreds of millions of daily users, you have to use a scale out database because they all need access to their own data and they all need it concurrently. That's the whole benefit, is the massive concurrency you can get when you have this scale out database, and all of these partitions are individually addressable and accessible for reads and writes. This is what you get. This is basically scale right there, right? So add more users, no problem. We add more partitions, and they can all address that data all simultaneously and seamlessly within there.
Yeah.
So let me talk a little about vectors in here, because this is really underlying kind of how these technologies work. These services like ChatGPT or all of this generative AI are all built on these things called these vector embeddings. And essentially what they are is just like an array of numbers. And you generate these by passing text into a model that will generate embeddings. And what they do is they provide semantic representations for that data so that you can associate. And the reason that is because these models are trained over massive corpuses of data. And whether it's sentences and books and of course GitHub repos, all this stuff, right? These things work by predicting the next word that is going to be that is in like a series of words there. That's how they go and they generate responses within there. But they also provide that semantic glue, if you will, for similar words. Like king is very in a vector space very close to say monarch, right? Because semantically those are very similar. And that's how things like vector search work. Is you say, I want to search for something, and then, or whatever it is I want to find in there, and then it's going to look for things that are semantically similar or close to that. And it does that by measuring the distance in this vector space between those things, right? And it will use something like a cosine or a dot product or Euclidean distance within there. And you can generate these vectors using anything. Of course, Azure OpenAI is very popular. There's the Ada 2 model that they launched with, and now there's a new one called Text 3. You can have different dimension sizes within there. So if you want deeper vector embeddings, you can go with kind of their default of 1536. You can even do smaller. You can do larger in there. And then there's also just kind of these the offline ones. You can use the open source Hugging Face and others that are within there, right? And all these things really allow you to basically do all of these types of things, like answering questions, of course, or detecting anomalies. This is how like a fraud detection would work. Is you have transactions that in a vector space all are very similar. Like there may be for a similar amount, from a similar time, at a similar place, for a similar thing. And then you see something that's completely off the wall, right? So in a vector space, that's going to be very different. That would trigger that anomaly within there.
Mm-hmm. Right.
Same with making personalized recommendations. You're looking for similar things, right? Or even searching for content like images. This is how Bing search works using the same type of technology underneath all of that there. So within our Mongo vCore, there, like I said before, there's these two types. There's this inverted file index, and this is good if you're using like have smaller, I guess, if you will, sets of data. And it's very accurate, actually, but you do have to tune it to get it kind of dialed in. The industry standard now is this HNSW, which is Hierarchical Navigable Small World. And this is a graph-based vector indexing engine. And it's very good. It's quite robust, and it's very accurate at scale. And also, it can support a fair amount of inserts and deletes efficiently within there. The difference or the problem is, or the roadblock that you will find with these things is that these vector databases tend to be very memory intensive. In fact, like Pinecone and Milvus are essentially all in-memory databases. Yeah. And kind of the trouble as well is if you have workloads that have a high volume of like mutations within the data, so high transaction volume, high concurrency, these databases aren't really designed to support this type of volume. It's very good at taking rather static data and then vectorizing and searching that. And it does support index rebuilds, but after a while of mutating the data over and over again, you do have to rebuild the index. And this itself is very memory intensive.
I bet. Yeah.
And this is where we're coming in with this new technology called diskANN. So this was the new vector. This is actually a suite of vector algorithms that are developed by Microsoft Research. And what is unique about this thing is that it is not entirely memory-based. In fact, there are two indexes that are designed as part of this. One is an in-memory index, which is very small and not very accurate. And what it does is when you do a query into Cosmos NoSQL with diskANN or using this technology, the first thing it does is that it will consult this index to find out what is the entry point into getting into the very accurate on-disk index, which is much, much larger, and then do the query from there. Yeah. And the benefit of this is that you get the benefits of speed within there because you've got this in-memory index, which you can quickly consult because it's small, and then use that to jump straight into the graph to go and get the more complete index for everything, which is on disk. Yeah. And what is very unique and interesting about this is that the architecture for diskANN is designed exactly for a service like Cosmos NoSQL because our database is designed with in-memory index and then super fast SSDs. In fact, the algorithm itself and the way it was designed is that the on-disk index should or needs to come from a very fast set of SSD storage within there, or at least it's optimized to go and work that way. And that's exactly the architecture that Cosmos NoSQL is built on, and why we have things like an SLA for latency. Like we're the only database in Azure that'll give you like a single digit millisecond latency for reads and writes. And the reason we can do that is because all of the storage is all stored on the same cluster. It's not, there's no remote disk for Cosmos. It's all stored in the same cluster right next to the in-memory index, which is used to then get into the data within there. So what you get is you get very fast response times, very high queries per second. And also because Cosmos is designed as a scale-out database, you can go and essentially do queries over very large sets of vectorized data. In fact, we think we've got something really special here in terms of being able to do vector searches, indexing and searches at a scale that we just have not seen before in the industry. So we're very excited about this. Yeah. This is going to be coming at Build. So for any of your viewers that are going to be joining us in Seattle or at least online, definitely want to keep an eye on Cosmos DB coming up here in, what do we got, about 2 weeks? No, 2 weeks.
Is it 2 weeks?
Weeks. Yeah. So end of May for this. So
it's the end of May.
This is very exciting. We're very, very excited to deliver this and build this for customers. So in fact, we'll have sessions on this. We've got labs that we're building on this and demos that we'll have for customers as well. So come check us out at Build. I guess I'm plugging our build coming up. So I've got some solutions I've been building and have built, and I just wanted to share them with your viewers now. And then let me show a couple things, and then I want to get into a demo. So first thing is I built this chat application. This is a very simple kind of chat GPT application using Azure OpenAI, of course, built on Cosmos NoSQL, running on Azure App Service, .NET 8, and then the whole thing is all .NET Blazor server front end within there. And there's a link you can see. There's a blog that I wrote on this thing. This thing I came out with about a year and a half ago, actually about a May is when I released this thing. And then there's a sample here. People can go and take a look at this over on GitHub, and they can go and fork or clone this thing, or they can, if they want, they can. There's a one-click deploy, and they can deploy this directly into Azure, and then just go ahead and run it if they want within there. So
now there's going to be thousands of ChatGPT apps out there.
Why not, man? That's the whole point, right? So, everybody wants to do this, or at least exploring how to do it. I try to make it easier for people to learn it. And the point one of the things that I try to show people in this is, how does the process for building these types of chat applications work? Like, how do you structure these types of things where you're taking a user question or input, you have to vectorize that data, or you have to go search or go to an LLM to go and provide a completion, and then store all of that as part of your chat history within there. I also show things like, how do you do token management? How do you manage things like the conversation history? This is another key aspect to building these applications, and why chat history matters is when you send a question to ChatGPT, like just say, what's the biggest lake in North America, right? And it will come back and it'll say, Lake Superior is the biggest lake in North America, and it may give you some stats and figures. If I go back and say, what's the second? If I don't give it the history of the conversation, it's going to come back and say, I don't know what you're talking about.
What are you talking about?
Yeah, like LLMs are stateless. They don't understand conversation history. You have to feed it some context so that it understands. And so you need to feed it the previous question and answer, or maybe a bunch of them, so that you can maintain that conversation and have that context within there. So this is
that's exactly how ChatGPT works, right?
What's that?
That's exactly how ChatGPT works.
It's exactly.
And they keep your conversation.
That's exactly. And it's what they're using Cosmos DB for, actually. For one of the reasons. They're using it to do a lot of other stuff. But that's one of the key reasons, is to provide that conversational context. And so this app will show you, like, how do you manage that context window? Also, how do you manage the tokens? Because LLMs have a token limit. Like, it's basically their request currency. And every request and response has a maximum number of tokens that LLM, that model, can support. And you need to stay within that window there. And you've got obviously the conversation history, and then also the size of the user question, and then also the size of the response.
Right.
Once you add things like RAG pattern and you start shoving a bunch of data into that payload, you've got even more stuff to do with. So this will give users kind of a good grounding on kind of the basics on just building a simple ChatGPT app. And then here's a little look at the user interface here. It's just very simple Blazor application within here. They can go and create a new chat session. It shows the tokens that are within there. So lots of good information within there, and they can go and download that and play with it. Next, I want to give a demo. So I wrote another app. This is a full RAG pattern application, and it's using our MongoDB vCore application, or our MongoDB vCore service. And this is full RAG pattern. So this uses the elements of the ChatGPT thing I just showed, but also does vector search against the database that I think a lot of users would know this. Like, everybody remembers, well, not everybody, at least older folks like me and you would remember AdventureWorks. You remember AdventureWorks database? That was the bike store from SQL Server from years and years ago, right? And they used that for years and years and years.
Oh, man, long time.
So I took that database and I made a Cosmos version of it, and it's all in NoSQL. And then I loaded it into our Azure Cosmos DB for MongoDB. I vectorized all the data within there. And then I can do vector searches against that, and then build RAG pattern applications doing that. So let me show you guys how that all works. So I'll pull up here. I've got a Visual Studio solution here. Well, let me start first from here. Here is this the right one? Hold on, let me scroll up. Sorry, I'm getting dizzy. Yes. So this is it right here. This is also in GitHub. People can go and clone this thing, or they can do a one-click deploy within there and play with this thing. And once they go and they run this thing and get it all set up locally, this is what it looks like in Visual Studio. So there's 2 projects in here. There's, well, 3. Here's my search app. So this is my Blazor server application here. I then have an Azure function in here, and I use this to actually load all of the data. So all the data gets read out of blob storage, and then I vectorize all the data, and then I store it in our Azure Cosmos DB for MongoDB. And then I have 2 functions in here. One does all the ingest and vectorization. And then I have another one in here I wrote that just shows you how you could quickly add another product, or you could remove a product within there. So this is a transactional database, so I kind of wanted to show kind of how easy it was to do that. And then I have this little shared library of stuff in here, and I've got a service layer for MongoDB, and then another one for Azure OpenAI service. And then I just DI these things into my projects when I go and launch this thing. So I'm going to go ahead and I'm going to launch this thing right now. And then what I'm going to do is I'm going to show you kind of the entire request pipeline for when I type a question into my LLM or into my chat app, and then what happens to it to go and do all of the vector search, the generation, and then the response that comes back to the user here. So let's give this just a second. I should have fired this thing up before I got on.
Hey, Simon, if you captured the URL for this project, can you put that in the chat for me? If not, we can do it later.
I can pull that back up, and I will grab it right here. Hold on. And then, Simon, I'll give it to you right there for you. And then while we're waiting for this thing to fire up.
Yeah, because I definitely want to check this out. This looks really interesting.
All right. So this thing's firing up right now. And I'll get this out of the way. And I'll get that out of the way. Okay, so I've got my Azure functions are started and my web app is started. I'll bring that over here. So here's my little web app right here. And there's nothing started in here yet. I'm going to create a new chat session in here, and then that'll give me a little text box down here at the bottom. Here, I'll make this a little bit wider so you can see. And I've got new chat session within here, 0 tokens. I can rename this thing. I can delete the session if I want. And then I've got a little text box down here, and I can ask questions now of our AdventureWorks database in here, right? So this is a bike store, right, within here. So I can do, hey, what bikes do you have? And I'm going to hit enter here, and then this breakpoint is going to get caught. So get chat completion async is basically going to take in my user prompt. Also, I'm going to pass in a collection name here because I can go and run vector queries against multiple collections in here. And then the first thing I need to do, because I'm going to do a vector search, is I want to go and generate the embeddings that I need to do that vector search. So I'm going to take text and I'm going to grab a vector, an array of vectors within here. So if I go and I hover over this thing, I'm going to have 1,536 flows basically within here, right? These are the vectors, right? It's not very user friendly within here, but that's okay. First, and then after that, I want to go and I'm going to create a new prompt message in here because everything I say that you see is a message within here. It's either a prompt or a completion. So I'll just go ahead and go right over that. And the next thing I'm going to do is I'm going to call this vector search async. Now this is calling out of this MongoDB service layer with it right within here. So let me just go and I'll step into that. And then I'm going to call, or I'm going to step through this thing here. And this is a bunch of code here. This is a bit ugly because it's all Mongo in here. But what I'm doing in here is I'm doing this search stage within here. So this is basically kind of a query or a vector search query. And then I'm passing in some different stuff. I'm passing in a vector array. So those are the numbers that's actually using to do the search. And that's going to search a property called vector that I've stored. Every single product, everything in this entire database all has this array, and it's all in a property called vector within there. And then that's the path for it. And then I'm going to say, just give me 10 results back. And then I'm going to get rid of the ID that comes back. And then also I don't need the vector. So I'm going to toss that away as well, because that just adds a bunch of nonsense to it here. So let me go back through here and convert that back to a list string. And I'm going to return that back. So now I've got within here a whole bunch of documents within here. And I can show you all of my documents. Well, I've got one in here, I guess. So here's a document that I've got back. I now want to go get my conversation history within here, right? Because I want to provide that history to my LLM. Well, I don't have any history here. This is a brand new session. So there's nothing going on within here. I'm not going to get anything back. And then I need to go and build my prompts within here. So this is the other key thing, is I need to build a pipeline, and I need to maintain that context history and also do it in a way that is going to be not blowing anything up in here. So this function in here is using a little library called Sharp token, and that's based off of open source library called tick token in there. And that's going to calculate how many tokens I'm going to need for all of this stuff in here. And then because I have a maximum number of tokens for this payload, because I don't want to blow up my LLM. Like if I throw a payload at the LLM that's too big, it's going to throw an exception. If I throw an LLM that's less than what the max is, it won't have enough tokens to generate a response, and I'll get something incomplete, or I'll get nonsense that comes back from it. So I'm going to go through and I'm going to step through all these things here. And here you can see the total tokens for everything I need in here for my, here's the RAG token. So I took and I tokenized all of the search results. I have some other tokens in here. There's my user prompt, and then I got a buffer within there. And then I'll step through all of this in here, and that worked fine. Great. And now I'm going to call my OpenAI service. So this is my other service layer that is going to go take my entire payload. So here's the conversation and the user prompt and all of my augmented content. This is the return that came back. And then I'm going to go generate a response in here. So let me step into this one. And here you can see I'm going to create a system message in here first, right? And let me walk up and show you the system message. So LLMs need some instruction to know what to do. Let's see if I can find this thing. Where are you? There you go. So I have a system message in here that tells this thing, what are you supposed to do? So you are the intelligent assistant for the Cosmic Works Bike Company, right? You provide helpful answers. Everything we're going to give you is going to be in a JSON format. Only answer the questions that is in the information below. Don't reference stuff that's not there. If you don't know an answer, just say, I don't know, right? So these are all the kind of basics that you have to give an LLM, because if you don't, it could respond with anything. Like I could have this thing and not give it any instructions. And if it's, say I'm a bike company and I say, give me a recipe for cookies, it will give me a recipe for cookies. But if I don't have any cookie recipe information in my database, well, then why would I give that kind of information, right? So you've got to provide a system prompt in there that's going to tell this thing how it needs to behave. So I've got the system prompt in here. I have my user prompt, of course, with all the user message in here. And then I'm going to go ahead and call the OpenAI service, which is get the chat completion. And that'll take a minute. See, that took about a second there, almost 2 seconds to go and do that. And then I'll go ahead and I'm going to return that. And I'm going to get back the response itself. So here's the response. And then also how many tokens were used in the prompt, and then how many tokens were used in the completion. And I want to store all this information, because just like I want to store the information for the chat history, storing how many tokens were used to generate these things is also an important piece of information. If you want to optimize these things for later, you want to know how much tokens are being consumed in producing these responses here. Right. So there we go. I'm going to let this thing fly now. So I've got this all done, and let's go back and see. And here you go. So here's all the bikes, and it just went and listed a bunch of bikes within there and said, let me know if you need any more information on a specific bike. And here is the tokens that were used in the completion here. This is 128. And then the prompt token. So this was the user question. and then also the whole payload that was within there as well. So that's kind of this in a nutshell is
that looks really cool.
RAG pattern application works.
Yeah, I hope everybody watching this is going, wow, I can do this at my company against our databases, and we don't have to, anybody can query the database now. We don't have to get involved in, writing queries or any of that stuff anymore, right? Which has been difficult for, people like us who have to, charge that stuff in the past, right?
Well, and also, like I said, this is all using .NET.
Yeah.
This is, and also another thing, this is a very naive implementation, if you will. It's just using the libraries directly. So I'm directly talking to our Cosmos Mongo. I'm directly talking to Azure OpenAI. I'm working on a new version of this thing right now that is going to use the semantic kernel, which is the LLM orchestrator SDK is kind of what they call these things, that allows you to connect all of these different things together and then build these types of LLM applications. And the beauty of those types of things is you can build a much richer, much more complex application that can handle a lot more different scenarios against a lot more different types of data. And that is really kind of ideally how, like, you would start with something like this is kind of help you understand the process and how it works. But when I do the next version, and we'll have a next version of this thing available for build, we'll show you how to build this thing in a much more complex way using semantic kernel. In fact, we'll show you the old way, this, and then how you would do it using one of these orchestrator SDKs.
Well, you've already given me ideas like, how can I take dotnettip.com and stick it in a database and do this, right?
Right.
I'm already thinking because I've always wanted to do like a chat thing for .NET Tips, but, I haven't found anything that makes that very easy at this point. So, well, that was awesome. I really appreciate it. We're out of time now, but that was really cool. I'm so glad you're on the 100th show because I thought that was really cool.
I just want to show you one more thing. I've got a very large solution accelerator. This is also built in .NET, all running .NET 8, same front end. And this one, by build, we were going to have disk ANN in there. And so I want people to check this one out too and keep an eye on this thing. We're doing lots of great stuff in here. It's all going to be AZD deployed. In fact, we've got that deployed in there now. But the next greatest thing is going to be this here, our solution accelerator. And this is essentially for how do you go and build these things to run in a production environment. So it's OpenAI running AKS, Cosmos NoSQL. It also uses AI search, semantic kernel, .NET 8, and Blazor server with disk ANN.
Wow. Man, I didn't know so much was happening over the Cosmos DB. But man, you guys are really busy.
Very busy. I could use a vacation, Dave.
Yeah, I bet. Now that you don't live in sunny Southern California anymore.
I know. What am I going to do? I guess I could just sit at my desk all day, right?
I know. Well, that's why Microsoft's up there. You get more work done because it's gloomy about 3/4 of the year.
Yeah, that's true. That's true.
See, in where I live, everybody's lazy because, we just go to the beach is like a mile away. So,
I miss it, Dave. I wish.
Yeah.
I'm going to go buy a vacation home someday, maybe, and then I can go and hang out on the weekends.
Yeah. You can buy a vacation home in Vietnam.
They're
a lot cheaper there. I hope they weren't too far away from the earthquake that hit early this week. I mean, they were far away from the earthquake that hit.
Oh, in Taiwan? Oh, yeah, that's far enough away. They didn't feel that.
Oh, okay. Yeah. That's. I thought I don't know about you. I mean, you've lived in Southern California, and everybody out there watching. Earthquakes are not a big deal here. We just go, yeah, okay, whatever. But the freak out in New York City and New Jersey the other day when they had an earthquake and everybody freaking out. I was going, no big deal.
I lived through Northridge and others as well. So I kind of laughed when I saw that. It's like a 4 something or whatever.
I don't know about you, but I'd much rather deal with a mild earthquake than a storm a massive storm hitting every other week or month,
That's true.
Or look at places that are in blizzard right now. It's freaking April and it's blizzarding in some places, right?
Yeah. Well, go check out Julie Lerman. She's
I know
the worst of it right now. So
I know she's always in the midst of it because of where she lives.
I know, right? Yeah.
Well, I better let you go because we're over time and I got a couple more slides to do. But I want to thank you so much for being on the show and stepping in when I needed you. And I'm so glad you were able to come on. And I'm excited about Cosmos DB again. I'm definitely going to download those sample apps and start farting around with them and see what I can find out. Because this is to me, this is really great applications for AI for doing things like this, right? And then using Cosmos DB. But I'm really glad I didn't know ChatGPT was using Cosmos DB, so that's great. I mean, they must have a massive amount of data in there now.
It's huge, and even like Teams has got. I mean, it's there is a lot. We're a very busy service, so. Yeah.
I did have one question I didn't want to forget before I go to your last question, and that is at the beginning of this your presentation, you were talking about the Cosmos MongoDB, the new one, and is that one easier to scale to geo-replicate than like the other Cosmos DB databases, or the same, or?
It doesn't replicate the same as our Cosmos NoSQL. So it's still a vCore based, and you could have a secondary on that, but you don't get kind of the seamless replication that you do with our NoSQL. That's really designed for that's kind of next level in terms of how that is designed. Because
I'm always thinking about the geolocation thing, and that's one of the things I like about Cosmos DB. It's so easy. It's so much easier to geolocate it than it is like something like SQL Server, right?
Yep.
Yeah. Okay, so your last question, because you've been on here 4 times by yourself, and I was thinking about this when we scheduled this, and I was going, oh man, I'm going to have to. If you come on again, I'm going to have to do one of those dinner jacket things like Saturday Night Live does. Whenever a guest hits 5, being a guest on Saturday Night Live for 5 shows, they get this like dinner jacket thing, and they get into this special club that Tom Hanks and all those guys are in. And so I was thinking we're going to have to do that for you if you come back on again. So I had to come up with a new question because you've been on so many times. So the one I came up with was, so as a, project manager / engineer, and you've been at Microsoft for, a long time now, what do you feel your job there is at Microsoft?
Right.
Not to put you on the spot, but I did send this to you.
I forgot. What's my job? My job is to, I guess the way I would characterize it is my job is just to help people be successful using Cosmos, to start and then get to using Cosmos. I've been developing for a lot of years, and I was a SQL guy for almost all of that, right? Yeah. I've been on the Cosmos team for 6 years, almost 7 years now. I'm not wasn't a big user of building document NoSQL databases before then. I never really had a need, and I never really was wholly aware. And not only is Cosmos a NoSQL or document database, but it's also this scale-out database. And I struggled with, how do I design an app that works, that scales like this? It's not intuitive. And I really kind of saw, like, if we were going to be successful as a service, I need to make that intuitive and easier for users, or help them find how to make that intuitive and easy for themselves. And so that's kind of how I view my job. I mean, my focus, more or less from an org standpoint, is to drive growth and reach out to the community and other stuff like that. But more fundamentally, it's, how do I help users just be successful and help them understand how can they use a database like this? Like, it's if when done right, this is the most efficient, cheapest, fastest database in Azure. There is nothing that can touch it. But it doesn't come for free. there are design secrets, I guess, if you will.
Sure.
And there's secrets because it's not intuitive, but knowing how to unlock that scalability is the key to all of it. And I'm trying to make that easier for users. I'm not there yet. There's a long way to go, but we are doing a ton of stuff. By the way, maybe you should invite me back for number 5, because one of the things that I'd love to talk about is all of the stuff we have done within maybe the last year that makes the service much easier to achieve, to get to that state where I have extremely efficient, extremely fast, and extremely scalable. And we're there. And you'll see more of this at Build as well. So there I am plugging again.
Well, thinking back to Cosmos DB when it started to now is dramatically different, right? And so I think you and your team are doing a great job, and so keep on doing that. We need more, we need better things like this, but not only better things, and all these capabilities, but better samples and to guide us to get there sooner than later, right?
So I love writing samples. You can tell, right?
Yeah. So thank you so much for being on the show 4 times. I really enjoyed you being on for the 100th episode. Thank you so much, and I hope to have you back on again, and I hope you have a great rest of the weekend with up there in Seattle with your family.
Thank you, Dave. It's my honor to be your 100th guest, and so thank you for having me, and looking forward to coming back again.
Thanks so much. Wow, that was a really great episode with Mark. I was I don't know how this episode is going to turn out, but I'm glad it turned out so great, and especially since the 100th one, I feel good that this was the 100th episode, because it was really great and a lot of great information that hopefully you didn't know, because I didn't know, and I'm looking forward to looking into all the great features coming out in Cosmos DB, especially after Build, because Microsoft's building up to Build now and not releasing anything, I think, until that happens. So I found this geek humor today. Actually, this is something I've been experiencing the last couple of weeks a bit. You have a friend. What do you do for work? I'm a programmer. And they think a minute and they instantly go, "Can you?" And what's the next words after that? "Fix my computer." I've been fixing people's computers the last couple of weeks. I've been setting up people's Wi-Fi in their homes just because I'm a software engineer, and because they can't, I can, I guess. And so I'm happy to help out, but that's the typical response. Actually, I won't wear Microsoft shirts in airports anymore, because people come up to me and start bitching to me about Windows or something like that. So I don't even do that anymore. I used to, until I got inundated, people talking to me at airports. And I don't mind talking to people. I just don't want to hear bitching at the airport, especially when I'm resting in between flights and things. All right. As always, please help me help the kids in India by donating to the Voice of Slum.org today. Please go there now, and donate whatever you can, even if it's $5 or whatever. The kids there would be really appreciative of that. They need our support to help these kids get out of the slums in Delhi, and train them and feed them and clothe them and all those kind of things that they really need. And most everybody watching right now has the ability to give, and so I hope you will go give whatever you can, as often as you can, to the Voice of Slum, because I think they're an awfully great organization that does a really good job, and I kind of miss going back, and I couldn't go back and see them last year, so I kind of miss that. Anyway, there's one of the kids that was speaking, so brave, speaking at the conference in front of hundreds of software engineers. Okay, well, I want to end the 100th episode. The next show will be on May 4th, because Simon's busy doing other things. So I hope you'll come back and watch Milan with me. He's going to come on and talk about, I forgot what we talked about. It's going to be on the show, mostly about doing side gigs and things like that. I wanted him to come on the show and share how he's making extra money doing side gigs and things like that. So he will be on May 4th. So don't forget, we'll be off for a month. but we'll be back on May 4th for that show. As always, please go and donate blood this weekend. If you live in America, send me proof and I'll send you some swag, including maybe a book. Because America is in a dire shortage right now, and it only takes a little bit of time for you to go donate some red blood cells, which can help up to 3 people. And I donated a couple of weeks ago. I'm getting close to 19 gallons now. I'm really close. I might have hit it by now. I'm not sure. I have to see when I go back in a couple weeks. So please go donate. I will be appreciative, and so will your fellow human and neighbor will be too. Okay? With that, thank you so much for watching the 100th episode. Thank you for everyone who's watched these 100 episodes, and thank you so much to Simon for being my awesome producer. And I'll see you on May 4th.